Okay, so this is the week 2 recap. So you may think that this is a bit late, and compared to the week 1 recap, I'm recording it much later in the relevant week. I think in general this will be when I usually get around to the recap, towards the end of the week after, because in order to see what sort of things that I need to say in the recap, I do need to get through looking at a lot of the discussion posts and assignments to see what kinds of things you might have the entire class might have sort of gotten a bit misled on, that may not have gotten through clearly enough in the lectures and that sort of thing. And so once I've gotten all that information and sort of processed a little bit, then I can come up with a recap and talk about the previous week in sort of a very short session and tell you the take-home points and that sort of thing. Let's see. So there's not any kind of slides for this. You can, of course, refer back to the slides from the previous week in order to sort of understand what I'm saying. But we will cover in the recap all of the arguments that I went through in the week that we are recapping, not just the ones from the lecture, not just the ones from the reading sequence. So, in week 2, we talked about some philosophy of science stuff. So in particular, we were looking at the issue as to whether or not science proceeds rationally. That is, whether or not when we move from one scientific theory to another, when one scientific theory replaces another, when we just come up with a new theory in general, whether that constitutes progress towards discovering some objective truth. That is, discovering the way the world really is, or the way the world really works, something to that effect. Now this was relevant and followed on from week 1 because at the end of week 1 we have, as I've already said, Nietzsche saying that the naturalistic scientific viewpoint and the supernaturalistic religious viewpoint are each equally irrational, right? So Nietzsche is not saying, or did not say, that the religious viewpoint, which he saw as declining, was being replaced by something less rational. But he wanted to say, contrary to the proponents of this naturalistic view, the naturalistic view wasn't replacing the religious one with something more rational. They were both irrational. So now we're going to see if any defense can be made of the idea that scientific theorizing, moving from one theory to another, whether this is more rational, whether it is rational just at all in some way. The first two arguments, the ones that we look at in the lecture for week 2, are trying to tell us that scientific progress or scientific methodology, the change, the putting forward of scientific knowledge is rational. It is more rational than other things, and it is at least not irrational. The two arguments that we saw here were one from Hilary Putnam. Hilary Putnam, incidentally, is a man. So Hilary, at some point, was a sort of more popular men's name. It's an English name. I mean, obviously it's in English, but I mean, it's particularly from the late 19th century and probably earlier. Men in England or from English families had that sort of name. So yeah, I just noticed that some people were referring to Hilary Putnam as a she in their responses to things. In any case, we have Putnam's argument, and his no miracles argument, and then we additionally have Karl Popper's demarcation argument. And so these are kind of doing two different things. The demarcation argument is supposed to separate scientific inquiry, scientific hypotheses, claims from non-scientific ones. So this plays into our goal of seeing whether or not science is in some way different from a religious worldview, because if the way that they make claims is exactly the same, then of course we should expect them to be equally rational or irrational, as the case may be. So Popper says, well, no, there is a difference, and the difference is that scientific claims are the sort that can be demonstrated as false. And this kind of hung some people up a little bit. And most people got the general idea, but it was the way that the argument was phrased, namely that an argument which is scientific is one that could be proven false. What this means, as I said in the lecture, and perhaps I didn't say it clearly enough, is that we can imagine some type of observation, some set of data, some scenario in which this type of claim would be shown to not be true, right? It would be falsified. It doesn't mean that this thing has to be demonstrated to be false in order to be scientific. It also doesn't mean that it can't be true. Now, it gets a little bit tricky here. Popper is going to tell us that we will treat as true, or we will say that for all we know, something is true, so long as it has not yet been falsified. But for all those things that have not yet been falsified, they only count as scientific if we say the following. Well, it hasn't yet been falsified, but we can imagine the situation in which it would be falsified. We acknowledge that tomorrow we might discover that this statement is actually wrong. For the time being, however, we'll treat it as true because it has not yet been falsified. Okay? So the key component is this idea that tomorrow we could discover and we would admit that this statement has been falsified. Popper says that non-scientific claims, pseudoscientific claims, are such that they wouldn't admit of that possibility. They would say, well, we think it's true now, and there's nothing that we could figure out, there's nothing we could find out tomorrow that would convince us that it's false. They just don't admit of that possibility. And so you can think of things like the way most people have religious beliefs. They say, look, I believe this, and I can't even think of anything that would prove to me that it's false. Maybe with some sorts of pseudoscience, conspiracy theories. So it's not just religious faith type things. There's all sorts of hypotheses that count here. So I use the example of conspiracy theories. A conspiracy theorist, if you give them some kind of evidence which looks like it should falsify their thesis, they'll say, oh no, that's just proof of a cover-up or something like that. Or, no, of course you'd say that. You're a blind sheep. You just don't realize the truth of the conspiracy theory or something to that effect. That's the kind of thing that would make something not falsifiable, or at least the person who's putting it forward doesn't acknowledge that it's falsifiable. That kind of thing is non-scientific. So conspiracy theories are non-scientific. Religious belief is usually construed as non-scientific for this reason. Pseudoscience, like perhaps astrology, is non-scientific because even though there are basically sets of experiments which demonstrate that the predictions of astrology are sort of, it doesn't actually predict anything. There are people who persist in believing it, who sort of say, well, look, that evidence doesn't do anything, I'm still going to believe. That makes sort of the claims of astrology pseudoscientific, non-scientific. So that's what he's kind of getting at. So some people said, shouldn't he allow for certain types of things to be proven as true? I mean, he does in the sense that we will treat as true things which have not yet been proven false, as long as we recognize, as long as we allow that they can be proven false in the future. And then one thing that someone brought up, which is a sort of an issue, a way of looking at it that I probably should have addressed. When Popper says that any thesis which is to be scientific has to be falsifiable, he means the theories themselves about natural phenomena. So someone asked, surely we don't want to allow that, that gravity doesn't exist, right? So in some sense, gravity is not falsifiable. That's true, but we have to be careful here. It's not that we will find out that there's no such thing as what we usually refer to as gravity, that force or something like that force which makes planets orbit around stars and all that kind of stuff. There is something there. What Popper wants to say is that our theories explaining whatever that is, those can be wrong. The theories themselves could turn out to be falsifiable, and we have to construct a theory, if it's to be a scientific one, such that we can imagine that there are conditions in which it could be shown to be false. If you construct a theory that's invincible to any type of future observation, it's not a scientific theory. Another sort of complication, someone brought this up, is that, well, is Popper's demarcation argument itself scientific or not? Well, it's not. It's not a scientific theory. But that doesn't mean that it's bad necessarily. So Popper, he may have had in mind that for the most part we want theories to be scientific. But he didn't think that everything non-scientific is therefore bad and nonsense. If something claims to make predictions, claims to be able to tell us about how things work, but is not scientific, then he would think that's a problem. His definition of what counts as scientific, well, that doesn't have to be scientific, right? So there is a lot of nuance in here to think about. So obviously his own argument isn't scientific, but that's not really a problem because it's not making a prediction, it's putting forward a definition of something. So hopefully that clears up a little bit what was going on with Popper's argument. Putnam's argument is a little bit more straightforward. It's certainly shorter. He's just saying if our scientific theories allow us to make lots of predictions and sort of intervene in the world, make things happen the way we want them to, well, that shows probably that our scientific theories are approximately right. If we successfully make predictions and change stuff the way we want it to, we must have some kind of working idea. We must have some kind of mostly accurate picture, of the way the world is working. So, and it's called a no miracles argument because if we assume that our scientific theories aren't getting an accurate picture of the world, even though they're succeeding so much, that would be really strange. It would have to be due to just incredibly long runs of luck or some sort of mystical interference from an outside agent. And those are both implausible. As I said in the feedback to a few people's quiz question, which dealt with this, you could think of it this way. Imagine that you are doing some kind of skill exhibition or sporting activity. So let's think about darts. If you throw a dart and you hit the bullseye once, you might think, okay, well, that could be lucky, right? If you hit the bullseye twice in a row, you might think, okay, still lucky. 3 times, 4 times, 5 times. You might think, okay, it could still be up to luck. At some point, that explanation becomes implausible. At some point, someone hits the bullseye so many times in a row, right, that you have to think it's up to skill. It's not up to luck. It's not because, some unseen force is helping them out, right? It's just because they're good at throwing darts. They know how to hit the bullseye. They know what to do in order to accurately hit that one place on the board. That's basically what the no miracles argument is like. To complicate it a little more, you'd want to say, well, look, someone knows how to hit the bullseye or has the ability to hit the bullseye if they can do it many times in a row under a variety of conditions even, right? So it doesn't have to be that it's deadly quiet. They can do it when they're a little bit tired, et cetera, et cetera. So think about the situations in which you would ascribe to someone some kind of sporting skill, the ability to hit a curveball, the ability to hit a bullseye, either with darts or with archery or on a shooting range, the ability to throw a pass 50 yards downfield and hit the receiver, et cetera, et cetera. Think about how many times in a row someone would have to do that before you could say, no, they're not lucky, they're good. That's the kind of argument that Putnam is making here. How many times do we have to get things right with scientific theories before we stop saying we're getting lucky and that, no, we're getting it right. We know what we're doing. We have a good picture of how things work. So that's the argument. That's, I mean, an analog to the argument that Putnam is making. And it doesn't have to be that you always succeed either, right? So you don't say that someone makes 30 bullseyes in a row. You don't say when they miss the 31st, oh, actually they can't do it. They were all luck. The 31st one that they miss, as long as they only miss one every once in a while, that doesn't prove that it was suddenly miraculous, all their other successes. Likewise, not every last bit of scientific theory has to make accurate predictions in order for science in general, the scientific method in general, to count as having non-miraculous success. So hopefully that clears that up a little bit too. Finally, talk about Thomas Kuhn's argument. So whereas Popper and Putnam are both putting forward a view on which scientific progress is, well, it's actually making progress, it's getting towards the truth, or that there is a big difference between scientific methodology and non-scientific methodology, Kuhn is putting forward a more sort of anti-realist perspective. So we see a realist perspective definitely from Putnam, and as a matter of fact, Popper has a realist perspective, although that's not exactly what's at issue in his argument. With Kuhn, we have this idea that the movement from one scientific paradigm for another, exchanging one scientific theory from another, is not a rational movement, right? It's not based purely on scientific evidence. It's not based purely on predictive success, so on and so forth. And sometimes it's not even mostly based on evidence and predictive success. So when he talks about the adoption of a new paradigm being based mostly on sort of social issues, right, on people's opinion and sort of acclaiming it, he's saying, well, it's based more on popularity. When he's saying that, so that's the first one of his arguments in the chapter. The second one about holism and about sort of the reference of scientific terms, he's saying, look, if scientific theory was this uniform progress towards the truth, then this word here, mass, as we use it now, should mean pretty much the same thing as mass way, way back when we first started using that term. So this argument's a little bit tricky too. We have to allow for some amount of change in the reference of terms. Otherwise, scientific theory can't move at all. But Kuhn's idea is that mass in the Newtonian picture and mass in the Einsteinian picture don't refer to anything remotely the same. And so we cannot say that there is progress from one to the next because they just are two different, entirely different concepts. Now, how much difference is allowable between the reference of two words like mass for it to be progress? What kind of change is allowed in Kuhn's picture in this holistic sort of network of terms? It's really hard to tell. And a lot of people write about to what extent Kuhn really makes a good point here. But that is his argument nonetheless, that this is his second argument at least, that the change in reference of terms from one scientific theory to the next is so discontinuous, right, is so much of a change that it's not sort of, improving upon the concept from one theory to the next. It's just entirely changing it. So one theory may get things right in some way, more so than the other, but it's not really necessarily a step forward, right? It's not this steady progress over time. That's not how science happens to work. Now, all of this is not to say that Kuhn thinks that science, he's not necessarily making Nietzsche's point. He's not saying that science is no better at describing the way the world is than non-scientific perspectives. Some people have taken Kuhn to be making this point, this kind of anything goes point. And there are, in the history of philosophy of science, there are people who interpret Kuhn this way. From what I understand, later on, maybe 40 years after the original publication of this, Kuhn writes a sort of updated version of his paradigm, I can't remember, standards and paradigms in scientific theorizing. He writes a foreword and he says, look, I never meant myself to put forward this radical anything goes view. He just wants to say science isn't what the realist tells us it is. Science isn't this steady, inexorable progress towards an objective picture of the world. It's this fundamentally social enterprise which is as much, at least as much affected by our own practical interests as it is by this sort of interest in knowing the truth and nothing but the truth. And so given that that's true, given that science is a practical social enterprise just like politics or anything else, the reason for which theories are adopted sometimes are irrational, right? They're not based on getting at the truth. They're based on accomplishing practical social goals. That's what he wanted to say, right? So he is putting forward an anti-realist position, but being an anti-realist doesn't mean adopting the sort of Nietzschean position, this position that science and non-science are equally valid ways of sort of exploring the world and figuring out how to do things. That's not what Kuhn is saying. So even though he's in a way refuting, responding to and denying what both Popper and Putnam say, he is not therefore endorsing what the sort of thing that Nietzsche would say. So hopefully this clears up things a little bit. It gives you a little bit more information, rounds out your understanding of these views, and puts them in a sort of historical and historical context, a context of the development of ideas about what science is and how it works. This is a big topic, and there's a lot more that one can read about it. And we have at ETSU at least one or two other classes that look at that, with science in the modern world, and then a philosophy of science course which runs every now and again. So this is definitely something that you can follow up on if it piques your interest. So that's the recap for this week. And again, as I said, the recaps will usually come at this later time in the week once I've had a chance to look over everyone's assignments, their contributions to the discussion about the relevant topics.